See my shared screen? Good morning,
Yes.
grade 7. We are now in the continuation of our topic. Okay. Again, this is in connection to the pure substance. Okay. Again, as a recap of what we had discussed last meeting, we have a pure substance. Pure substance, we're talking about pure substance. Okay. Pure substance can either be right, an element or a compound. Okay. An element. How can we say that this particular thing here is an element? How can we say that this particular thing here is a compound? How can we determine an element and a compound? Okay. An element is defined as pure substance that cannot be chemically decomposed, or we cannot actually chemically separate that particular substance. Like for example, oxygen, hydrogen, nitrogen, phosphorus. So those are elements. Okay. How about at room temperature, at the normal atmospheric pressure, most elements
Sir,
are
I have
solid.
a question.
Yes, Travis.
What is the kanang, diba, you have like a match. What is the side of the match made of, the box? What is it made of to make the fire light?
Oh, yeah. It is actually phosphorus. So let's move forward, right?
Okay.
Most of the elements are solids, while few others are either liquids or gases. Okay? Of all elements, right? Only 2 are liquids at normal room temperature. Okay? Your mercury and bromine. Mercury is the only liquid metal. Okay? It is also poisonous in humans. It can cause poison in our nervous system. Okay, because this is actually one of the this is the only element which is in liquid metal. It is a metal but in liquid form. Metal in the sense that it conducts electricity, and it is also a good conductor of heat. Okay. On the other hand, 11 of the known elements are gases. Okay, or the noble gases. This includes oxygen, hydrogen, nitrogen, chlorine, and helium. Okay. Most of the elements are also classified. It's either non-metal or metal in nature. Okay. While the rest is referred to as metalloids. Okay. Metalloids have both metallic and non-metallic properties, just like your ceramic capacitors. Okay. These are metalloids. Later on, we will discuss about what are the usage of these metalloids. Okay. Semiconductors. Periodic table of elements. Okay. In the periodic table of elements, it is a tool that aids you in identifying the physical and chemical properties of elements. As you can see, in your periodic table of elements, your elements is being classified according to, number 1, their form, okay, their phase. Number 2, in a room temperature, right? Number 2, how do they react, and so on. Okay. It helps you remember the chemical symbols of elements, their atomic size, atomic properties, and non-metallic properties. Okay. The rows, take note, or the horizontal arrangement of periodic table are called periods or series. Okay. Rows. And the columns, okay, or the vertical arrangement of elements are called groups. Okay, group often called as a family because the elements in it have similar chemical properties. Okay. These are the families. Okay. In group 1A, it is called alkali metals. In group 2A, it is called alkaline earth metals. In group 3A, it is called boron family. In group 4A, it is carbon family. In 5A, it is nitrogen family. In 6A, it is oxygen family. In 7A, it is halogen family. And the last one, which is in group 8A, which is considered as the noble gases. Okay, if you're going to look at your periodic table, this is your group 1A, group 2A, okay, group 3A, 3A, group 3A, 4A, 5A, 6A, 7A, and 8A. Sure, why you didn't included this elements here? They're called transitional elements. Okay, we usually categorize some of the elements as transitional elements or transition elements, right? So talking about the columns, again, what is your column again? This one, it is called as this one, the one I had discussed a while ago. Columns, family or family or
Groups.
groups, correct? Okay, and the rows, this one is called rows, periods or series. Are you still with me?
Yes.
Yes.
Can you hear me? Okay, again, the rows or horizontal arrangement in the periodic table is called periods or series. This one, okay, periods or series, okay. And the columns or the vertical arrangement in your periodic table is called groups or family. This one, groups or family, okay. This is the groups 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. This is the noble gases, okay.
Oh no.
Then the helium, neon, argon, krypton, xenon, radon. Okay. Metals, non-metals, and metalloids. What are their significance in the periodic table? Do you have any questions so far?
No.
No. You need not to memorize them. Okay. I am not requiring you to memorize, but rather I'm requiring you to familiarize. Familiarization is different from memorization. Okay. That is why your periodic table is there in order for you to be familiarized. I am actually teaching you how to familiarize with the help of your columns and your rows. The
Sir,
family and what?
what is the
The
difference of
periods.
helium and air?
Again, Travis,
What
what
is
is
the
your
difference
question?
of helium and air?
Helium and air? Air?
Yes.
Air is a mixture of gases. Helium is an element.
Oh.
When you say mixture of gases, it has a lot of components like dusts. What else? Nitrogen, oxygen. Correct?
Yes.
Helium and air?
Air.
Huh? I don't understand your question. Air. Okay.
What's the
Air is a
rules
mixture of
again?
gases. Again, air is a mixture of gases. It is not just an ordinary air. Okay, it contains a lot of pollutants also. If in case you're living near the factories, okay, it might bring you with carbon monoxide. It might bring you with carbon dioxide. It might bring you with some of those poisonous gas. Right? Okay. Examine closely your periodic table of elements. Do you notice the heavy ladder-like line that passes through boron, aluminum, silicon, okay, germanium, astatine, okay? I will let you see. This line is called the Sanderson line. Okay, this one. Boron, okay, aluminum, silicon, germanium, arsenic, antimony, tellurium, okay, polonium, and astatine. This one, this line is called the Sanderson line. Again, Sanderson line separates the metals from non-metals. Simple, right? This is now your hints in the periodic table without you knowing it. Okay. What is the importance of having Sanderson line? Again, this separates the non-metals from the metals. Okay. it divides metals from non-metals. The elements to the left, okay, of the Sanderson lines are the metals to the left, okay, to the left, okay, this one are the metals, okay. The elements, while those to the right line are non-metals. Elements adjacent to the Sanderson line are called metalloids, okay. It has a property of metal and non-metal, meaning to say that they are semiconductors. They might, again, conduct electricity and heat. It depends upon the element, and it depends upon the room temperature. Okay. Physical properties of metals and non-metals. In metal or metals, it's lustrous or shiny. Ductile, can be drawn into wires because they are ductile. Malleable, can be hammered into thin sheets. Good conductors of heat, of course, and electricity. That is why these are used in your wires. Okay. High melting point, usually solid except mercury at room temperature, because mercury is the only liquid metal. How about non-metals? Non-metals are non-lustrous, meaning to say it's a dull appearance, non-ductile, it cannot be drawn into wire, brittle as solid, okay, poor conductors of heat and electricity, okay, maybe solids, liquids, or gases at room temperature. Okay, how about metalloids? This is now metalloids. Metalloids have properties between metals and non-metals. They have the property between metals and non-metals. Example is silicon appears lustrous, but it is not malleable or ductile because it is a metalloid. It is a poor conductor of heat and electricity compared to metal. Okay. Germanium is a lustrous and brittle solid with high melting point. Silicon, germanium, arsenic, antimony, and tellurium are semiconductors. They are actually used by your electronic devices. Your capacitors, resistors, transistors, they're using this one. Okay? Because they're considered as semiconductors. Question so far? Question?
No questions.
No, no.
All right, let's continue. Semiconductors are the materials whose electrical conductivity lies in intermediate between the conductor and an insulator, just like your capacitors. Have you seen capacitors in your
No.
electronic devices? You didn't see a capacitor, just it looks like a battery in your
Yes.
devices
Isn't like inside the phone when you open the back?
inside your phone. Your phone has a micro
Chip.
capacitors, meaning to say it has a smaller version, the smallest capacitors and microprocessors. They're using microchips there compared to your devices like your refrigerator, your washing machine. They're using capacitors there and resistors. So those are the examples of your semiconductors. Okay.
These phones have like antennas inside it.
Your phones has also
Antenna.
microchips, capacitors in micro also, smaller version. I've known this one because I am also a cell phone technician. I repair computers and cell phones. That is why. Okay. Semiconductors are the foundation of modern electronics like transistors, solar cells, and diodes. Okay. Silicon is used to create most commercial semiconductors. This is really common in your devices. They're using silicon. Okay. Uses of metals and non-metals. Metals are both pure and compound form. Have extensive uses in industries, home, and etc. For example, copper and aluminum are used in carrying electrical currents. Your wires is made up of copper and aluminum. Okay. Iron, aluminum, and copper are used to make utensils for cooking. Okay. Chromium and nickel are used for electroplating. Okay. Iron, chromium, and nickel are used for making stainless steel. Okay? Silver, gold, platinum are used in making jewelry. Okay? Your jewelries. Sodium compounds are used in making soap, detergent, and etc. Calcium compounds are used in making cement, bleaching powders, or plaster of Paris. Calcium carbonate, for example. So that is actually some of the uses of metals and nonmetals. Elements essential to life. Okay, there are a lot of elements that are essential to life. What are those? There are elements that are essential to life. Their absence may result to death or severe malfunction of an organism because they are considered as vital. They are considered as vital in the metabolic processes. Okay? In an organism's metabolic processes. Okay? These are the elements classified as 1. Bulk or structural elements. They're the major component molecule or components of molecules in the human body. These are the building blocks of compounds that make up an organism and muscles. This includes, okay, hydrogen, carbon, nitrogen, oxygen, and sulfur. We are actually made of hydrogen, carbon, nitrogen, oxygen, and sulfur. Absence to those may result to death. As simple as that. Microminerals. Okay, the second one is microminerals. They are the nutritionally important element or elements that are required in the amounts of greater than 100 milligrams per day. Okay, this includes sodium, okay, potassium, magnesium, calcium, chlorine, and phosphorus. These provide essential ions in the body fluids and form the major structural components of the body. Or this is actually used in some of the metabolic processes. Your vitamins, your minerals. Okay. The third one is trace elements. These are elements needed by the body in very small amount, but with large effect on the human body. These elements are involved in the metabolism. Okay. There are 3 prominent biologically active trace elements like iron, zinc, and copper. We really need iron, but not overeat iron. We really need iron, we really need zinc, and we really need copper. Okay? This is for our metabolic processes. In fact, pregnant woman needs all of these for the developing child or developing baby. This is the reason why there are a lot of birth defects because of the lack of this. Again, this may result to death. Other essential trace elements are iodine, okay, selenium, arsenic, boron, manganese, molybdenum, vanadium, nickel, cadmium, tin, lead, fluorine, okay, cobalt, and chromium, but in a small amount. Okay, again, in a small amount. The over amounts of these elements can actually cause diseases if it case. Too much of this can cause disease. Some foods, including cereals, milk, bread, and margarine, are fortified with trace elements, fortified with zinc, iron, right? If you're going to read the label there, it is fortified with zinc, iron, selenium, and all of those, okay? But in a minimal amount. Let's move now to compounds. This is the second pure element. How can we distinguish compounds to an element? Okay, compounds can be chemically separated into component elements. Again, the very basic definition of compounds, they can be chemically separated into component elements. Like for example, your sodium chloride, okay, your salt. Your salt can be separated into sodium and chlorine. Okay, the proportion of elements in compound is fixed. Okay, like for example, if you're going to have a spoon of salt, it has a 50-50 component of sodium and component of chlorine. Okay, because they are fixed. The properties of compound are different from the properties of its component element. Okay. An example of compound is sugar, which is composed of carbon, oxygen, and hydrogen. Okay. C6H12O6. That's your sugar or glucose. However, sugar exhibit properties that are different from the properties of each element. Okay? Meaning to say, they actually what? Have a common properties as a sugar compared to the separate elements that compose them. Okay? Chemists represent compounds using formulas based on symbols of the elements in the compound. Okay, like for example, sodium chloride or salt, it is NaCl. Okay, so those are the representation based on their composition. Acids, bases, and salts. Okay, compounds may be classified as acids, bases, and salts, which definitions may be operational or conceptual. When you say conceptual or conceptual definitions, these are based on the behavior of acids and bases, okay, as explained by different theories of Arrhenius theory, Bunstead-Lowry theory, and the Lewis acid-base theory. We will discuss this later in your higher years. Okay. An acid is a compound that exhibits the following properties. If it is an acid, it tastes sour. It tastes sour. Okay. It reacts with some metal or corrosion. It can corrode the metal because it is an acid. Changes blue litmus paper. This is now our pH indicator to red. Okay. Reacts with base to form salt. Okay. This is now the acid-base reaction, the neutralization process or neutralization reaction. Reacts with some metals to produce hydrogen gas. Okay, some of the acids react with metals and form hydrogen gas. Just like when you use what? Muriatic acid. If it acts with the metal, it can actually produce some hydrogen gas. And it is actually poisonous. How about base? Okay, base is a compound that exhibits the following. Okay, has a bitter and biting taste. Okay, has a bitter and biting taste. Has a slippery, soapy feeling. That is base or base. Changes red litmus paper, okay, our pH indicator, to blue because it is basic. Reacts with acids to form salt. Okay, the neutralization process. Very few reacts with metals because it is basic or base. Okay, a salt is a product of neutralization reaction between an acid and the base. Okay, like for example, if you going to have hydrochloric acid, okay, HCl, and sodium hydroxide, it will create sodium chloride or salt plus water. That is the reaction or the neutralization reaction. But be careful with this. Why? Because the reaction of hydrochloric acid and sodium chloride is exothermic. When you say exothermic, it releases heat. It can actually cause explosion in the process. That is why
Ow.
you need to be careful with handling chemicals, especially with hydrochloric acid and sodium hydrochloride. And of course, sodium hydroxide. It can cause explosion. Okay? Let's move forward. I'm sorry I
Sir,
cannot do the laboratory. It's supposed to be
sir, I
or
have
be
a
doing this
question.
one. Yes, Travis.
What happens if you mix ammonia and bleach?
Ammonia and bleach. The reaction there is ammonia is a base and bleach is an acid. So there is an acid-base reaction. Okay, but as far as I know, it will create again sodium chloride and water in the process of mixing. It is also exothermic. Just be careful with that. Okay, that is exothermic, meaning it actually releases energy in the process. It releases heat in the process. Okay, they are using this one in in your hair dyes, okay, ammonia and bleach, okay, and other salons also are using this one. Any other question? Supposed
No.
to be, we will have an experiment with regards to this, but then again, we cannot do it as of the moment. Okay, all we have to do is to have the theory. Okay, common list of acid bases. Okay, we have common acids, hydrochloric acid, referred to as your muriatic, and your gastric acid found in your stomach. Okay, you have your hydrochloric acid in your stomach. Okay, sulfuric acid found in the fertilizers, sulfur. Okay, and in the volcanic mounts, you have a lot of sulfuric acid there. Nitric acid found in the acid rain. Okay, citric acid found in lemon, lime, and orange. Okay, carbonic acid found in the carbonated drinks, your soft drinks. Okay, lactic acid found in sour milk, yogurt, cottage cheese. Okay, it is actually lactic acid. Tartaric acid found in the grapes. Acetic acid in your vinegar. Your vinegar is acetic acid. Okay, how about common bases? This is bases. We have sodium hydroxide found in your lye or dye used in soap making. Calcium hydroxide called the lime water. Okay, potassium hydroxide known as potash, dissolved grease. Okay, magnesium hydroxide, an antacid called milk of magnesia. Okay, ammonium hydroxide, a 2% solution, is used to revive patient to have fainted. Okay, the one being actually put in a cotton, and you let your patient smell. Okay, in order for it to be revived if in case he or she fainted. Kuyapan. Okay, that is actually used in medical. Sodium bicarbonate, your baking soda, used in baking. Sodium hydrochloride, okay, used as bleaching agent. What else? How about calcium carbonate? Okay, calcium carbonate are being used as antacids in your stomach. Okay, your Semeco, Cremil S, those are calcium carbonate. Okay, they're used to neutralize the acids in your stomach. Question? That is base. I'm sorry for the misspelled word there. That is bases or base. I think it is understandable, right? I think
Yes.
because we're talking about acids and bases, correct? Okay, let's move forward.
Yes.
Handling acids and bases. In handling acids and bases, okay, you need to have an extra idea on handling them. Do not handle them by yourselves, okay? Or else you might have an accident, okay? Strong acids like hydrochloric, sulfuric, phosphoric, and nitric acid, and bases like sodium hydroxide, calcium hydroxide, and potassium hydroxide can be corrosive to human tissues. Again, can be corrosive, meaning to say that it can damage your tissues. Okay? Safety precautions should be practiced when handling chemicals in the laboratory. Supposed to be, again, we will have our laboratory experiments, but then again, we cannot actually do it as of the moment. Use hand protection or gloves in handling acids or bases. Okay? You can use surgical gloves or you can use your rubber gloves. Okay? Wear safety glasses or goggles because some of them are very explosive. Take note, explosive. It can damage your eyes. Okay, do you have any question? Any concerns that I need to attend?
Nope.
No.
Travis, RJ, Levi, please turn on your camera. Okay. Mariana, Sebastian, Jaden, Jairus, do you have any questions so far?
No.
Take note that this will come out in your exam. Again, this will come out in your exam, right? This is the reason why I'm rushing this over. We don't have enough time to do this. Or else, you might be taking an exam without discussion. You choose. I'd rather discuss this in a rush rather than letting you answer your exams without discussion. Do I make myself clear? Everybody?
Yes.
Okay. Again, use hand protection like gloves, rubber gloves, or surgical gloves. Before in my class, okay, when they handle chemicals, especially these hydrochloric acids, they also have their laboratories. Like for example, in this case, I let them dissect a human heart, a swine heart, not a human because
What?
human is smaller. This is a swine heart. The composition of chemicals here is 60%, 40% water, and 60% the agent for um, fixing agent. Okay, the fixing agent is the chemical being used to preserve, or the preserving agent. Okay, so in handling those, I asked them to use again a hand protection, a gloves, and of course wear a laboratory gown. That's the third one. You need to wear your laboratory gown for your protection. If we will have the laboratory. Okay. What activity? What are the things that you're talking about here? Okay. Why do I need to open the activities? Wait. Okay, everybody, why do I need to open the activities?
We want to answer it early.
You want to answer it early?
Yes.
We are still in the discussion part. I'll be opening those activity on the activity part. Have you seen the process? Okay. The process here is discussion. After discussing, okay, I'll let you do the activity with a time frame. But in this second module, there is a changes, or there are a lot of changes in your activities because I'll be opening them in a limited time. Okay, I'll be opening them in a limited time. Let's move forward. The fourth one, if an acid or base enters your eyes, okay, or in contact with any parts of your body, flush the affected part with plenty of water and go to the clinic at once. You need to double check, especially if it is an acid. Okay, again, it can cause a serious damage in your tissues. Okay, dispose the chemicals properly. Improper disposal of chemicals can lead to poison. Like for example, if you're going to mix your chemicals with the other chemicals in your kitchen, it can cause serious diseases. It can cause also damage, or it can cause death. Okay, ingestion of some of those acids can actually cause death. Okay. Neutralization reaction. Okay, the process of combining an acid and a base is called the neutralization reaction. Okay, the neutralization reaction is the principle involved when a person with hyperacidity, okay, hyperacidity takes an antacid like aluminum hydroxide or magnesium hydroxide or calcium carbonate in a small dosage. Small dosage. But too much of them actually can harm your stomach. Okay, you need your acid in your stomach Why? Talking about digestive system, it needs to be acidic in order to activate some of the enzymes. Okay? A safe way to find out whether a substance is an acid or a base is through an indicator, your pH indicator. Okay? An indicator is a substance that exhibits one color when added to acids and another color when added to bases. Okay? Just like your litmus paper. That is your pH indicator. We have litmus paper in our laboratory, but as of the moment, again, we cannot perform any laboratory works. The acidity or basicity of a substance can be described using a pH value. Okay? Take note, pH value. The pH scale ranges from 0 to 14. Okay? 0 to 14. A neutral solution has a pH equal to 7, which, or a pH value lower than 7 indicates that the solution is acidic. If it is inside